Let's have a look at these very special type of equations we know as quadratics. Hey. Basically, the solution is solved on this one simple idea. If you have two things multiplied together and you know the answer is 0, there's only one way that can happen, and that's if one of those things is 0. Multiply something by 0, you get 0. In fact, not only two things, if it was 3 things, 4 things, 5 things, it's still true. One of those things must be 0. And that's how we solve quadratics. We try and factorize it. So once we've got as factors, we're saying these things multiply together to equal 0. Multiply 18, add to give 9, 6 and 3. So either the x plus 6 is equal to 0, or the x plus 3 is equal to 0. Now some people write that down as a first line, others go straight to the solution. Doesn't really matter. So we've got either x equals negative 6 or x could be negative 3. Of course it can't be both things at the same time. I point this one out just to highlight something. There's a very common mistake that happens when people are working quick. They'll solve this and just have the solution x equals negative half and forget about the x sitting out the front. It's still a factor, it's still a possibility that the x could equal 0 there. But as I say, it is a common one that's missed when people are working a bit too quick. Not everything factorizes, of course. So we have that beautiful formula that I was talking about the other day. There it is in all its glory. Negative b plus or minus the square root of b squared minus 4ac all over 2a. It allows us to solve a quadratic like this, because you look at it and you go, oh, well, it's not monic. What multiplies together to give negative 8 adds together to give 5, and you go a bit like that, and your head starts going and your eyes pop out, and you don't spend too long because you've got this beautiful formula. Even if it does happen to factorise and you don't see it straight away, if it's taking you too long to think of it, you've got a formula, use it. You know, it's going to be quicker than sitting there for 10 minutes coming up with the right factorisation. So, negative 5 plus or minus square root of 25 and 37. No, that's not a perfect square, is it? So no, it was good we stopped looking for those factors. They weren't going to be there. So square root of 57 over 4, that does not simplify down. So that, of course, is an exact answer. In mathematics, we like exactness, preciseness. We tend to leave things like that. I know in science, they're a little bit more paranoid. And they go, what? What is that? And they have to go to a calculator and get an approximate answer, and all of a sudden they're comfortable. And they say, oh, right. So they might be working out a calculation, how long something is. See, us mathematicians are quite happy saying, how long is it? Square root of 57. But for some reason, these scientists can't cope with that. They need a number. So, don't waste time approximating if they don't ask you to. We like exactness. Now, that means you get something like this, where you want to make x the subject in something, and you think, whoa, hang on, I can't do that. Well, yeah, you can, because really that's just a quadratic equation if you rearrange it. You've just got to determine which pronumeral. In this case, it's going to be x, because that's the one that's squared. So rewrite it, make everything equal to 0. You treat the other pronumeral as if it's just a constant number. So the constant term becomes 3 plus y. So let's solve it. Negative b, negative 4, plus or minus square root of b squared, 16, plus or minus, not plus or minus, sorry, minus 4ac, so minus 4 lots of 3 plus y, all over 2. And no, a bit more tidying. See, I noticed 4 is a common factor, pulled that out. Square root of 4, of course, is 2. We've got some cancelling that will happen with the 2's as well, eventually. And then we have it. X is now a subject. Now, if I was talking about a graph, x equals minus 2 plus or minus the square root of 7 plus y, what is that saying to me? We have ended up with it's still a parabola, but instead of making y the subject, it's told us that, hey, the axis of symmetry is negative 2, and then it's going to be plus or minus the square root of 7 minus y. Will then get us the other values. It's just a different way of writing the equation. It's A lot more unusual, and that's why we don't see it that way, but it's certainly possible to write it that way. 1G. Dun, 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 dun.